All right, welcome back, ladies and gentlemen. Now it is time to actually practice applying our transformations as well as determining the domain and range. And again, as promised, I have the kind of a little guide for you to follow when identifying the transformations of a function. And you can see I'm using function notation because it doesn't matter what the function is, right? We have 12 parent functions that we are going to be applying these transformations to. And each of those transformations apply the same way, no matter what the function is. Now, the first example is a little bit more different because you should already know how to graph a line. And this one's actually confusing when you think of this as actually just transformations. And I think the easiest thing to look at a line is to just treat it as all vertical, everything outside of the function. So you can see we have a vertical stretch of 2 and then a shifting down 1. Or you could also just go back to old school here. We have a slope of 2 over 1 and a y-intercept of -1. So I know my graphs here are a little bit off because I kind of have some small point, but I'll try to do my best. So we have -1, and then we're going to go up 2 over 1. Oops, yeah, over 1 right there. And there you go. And oops, yeah, down 1. Oh, up 2. My bad, I can't even graph a line. How embarrassing is that? So that's up 2 over 1. There we go. Okay, and then you can connect those 2 points and then you're good to go. Now, in terms of the domain, this is what we've already covered in obviously our implied domain. You can look at the graph and hopefully know what the implied domain is from there, which in this case you should say there are no restrictions. This graph has a domain of -infinity to infinity. And then especially if you're good at graphing, you can recognize that obviously, there's no discontinuities for a line, so therefore the domain is all real numbers. Immediately, we can look ahead and we say, this is a quadratic. The domain is -infinity to infinity, right? There are no restrictions on our domain for a quadratic function. Now here we can see our transformations though, again, from the parent graph. Remember, this is going to be the parabola, and this graph is being shifted 3 units to the right and shifted 1 unit up. So I'm going 3 units to the right and then up 1 unit. Now, when I'm graphing these, I just ask my students to go ahead and just give a rough sketch. You should technically be able to at least move 1 point to the left and right and up, at least have 1 point on the graph. And then from there, we're not using a graphing calculator, so we just want to be kind of close. But the really idea is, yes, you should know that what the transformations are and the domain. I'm not really concerned with my students as far as how well they graph the function. In the next one, you can see that I'm multiplying by a negative. So I know that's a negative on the outside. So it's going to be a reflection about the x-axis. And I know I'm also multiplying by a number larger than 1, like the absolute, like 2. Forget about the negative, but 2 is larger than 1. So that is going to be a vertical stretch, right? Because all the operations are happening outside of the square root. So therefore, this is going to be a reflection as well as a vertical stretch. And actually, you know what? Yeah, I think this might be a little helpful to go ahead and first graph the original parent graph for you. So let me just go ahead and do that real quick. So this graph would look something like this. Therefore, you guys can just kind of get an idea of what my transformations are being applied. Now, the sine graph is obviously something that I know we're not very, very familiar with, but that is okay. We're just going to kind of do a rough estimate here of the sine graph. And hopefully you just see, though, that this graph is just being shifted up 1, and we're adding 1 outside of the function. So all that is simply going to do is just move my graph up 1 unit for each of these kind of points. So it's going to be a vertical stretch. I'm sorry, not a vertical stretch. It's going to be a vertical shift. Now, when we look at the domain, it doesn't look like there's any discontinuities, does it? So the domain here is -infinity to infinity. Oh, I said find the domain and the range. Excuse me. Sorry about that. I'm going to have to go back. If we look at the range here, you can see that this graph is bounded, right? It has an absolute minimum and an absolute maximum. So the range here is going to be from 0 to 2. And both of those values are included in the domain. Over here, we can see that my domain is going to be from 0 to infinity, and my range is going to be from -infinity to 0. So again, remember infinity and negative infinity are not included. 0 is included, so that's why we want to include them. Here, my range is going to be from 1 to infinity. That's how low the graph goes to how high. And over here, my range is going to be negative infinity to infinity. Okay, now let's get into the cubic function. And knowing what the cubic function looks like, that is going to be our lovely S-curve graphs. So it's going to look something like this, right? It's not perfect, but it's going to be the best I can do. And now let's go and identify our transformation. So now we're multiplying by negative inside of the function. So that's going to be a reflection about the y-axis. We're multiplying by a 2. So instead of that being a vertical stretch, that's actually, instead of that being a vertical stretch, that is actually going to be a horizontal compression. So again, you can think about that as like being the same thing. It's going to have that similar impact, but it's just not going to be exactly the same there. I'm sorry, that's going to be a horizontal, yeah. Horizontal. Now I'm mixing all these up. That's going to be a vertical stretch. This would be a, yes, that would be a horizontal compression. There you go. Vertical stretch, horizontal compression. And then also we're going to shift the graph down 1. Okay. So I'm just going to make this graph a little bit skinnier just to kind of represent that. And we can see that so we're reflecting the y-axis. We have a horizontal compression, which is a factor of 2, and then we shifted the graph down 1. Now, since this graph is a continuous graph, the domain and range are still going to be all real numbers. So it's negative infinity to infinity, and my range is negative infinity to infinity. And that brings up a point I want to bring to you is when you have a function that is all real numbers for the domain and the range, it doesn't really matter what you do to apply transformations. It's still going to be all real numbers. So the transformations are not going to impact your domain when you have a function that is already all real numbers. The next function is going to be a absolute value graph. And if you remember, that was our famous V-shaped graph. So that's going to look something like that. And now we just need to identify what is going to be the domain and range when we have a couple of different operations. Now, if you look at our notes, in the guided notes section, I kind of talk about this, and I also think I talk about here. If you see, when I'm identifying A, B, and C, I'm referring to it when my variable inside has a coefficient of 1. So that means if I have a coefficient, I need to factor it out. So this graph is not being shifted 4 units to the left. What I need to do is factor out the 2, and now it is in my form of B times X minus C. So now you can see that this graph has it being multiplied by 2. Again, that's going to be a horizontal compression, so it's going to be kind of skinnier. And we're now shifting the graph 2 units to the left. Okay. Now again, everything that is being applied here is impacting the graph horizontally, right? Because everything is inside of my absolute value. And this is important because when we're thinking about this, the domain is already all real numbers. So if I just shift this graph left or right or stretch or compress it, that's not going to impact the domain at all. And the same thing, if you have a range that is 0 to infinity and you shift the graph left or right or do whatever horizontally, it doesn't matter. It's not going to impact the range here either, because obviously you're not doing anything vertical as far as a transformation goes. The next graph here is going to be our cosine function. So recognizing what the cosine function is, that's going to be very similar to our, did I do the wrong graph? I did. I can't believe that. That is not the cosine function. I can't believe I did that. Jeez, oh man, what's wrong with me? Let's take the cosine function. There's that. And then let's actually delete that. There's the cosine function, FYI. I can't believe that. That's embarrassing. Sine function looks like this. Nothing is changing with my sine function. But the graph, if you recall, is from there to there. So when I shift it up 1, then you're going to get this red graph. That's going to look like here. So it's the same. The values are not changing for my domain and range, but I drew the wrong graph. I can't believe that. In this case, you can see we are multiplying by negative outside of the function. So inside of the function would be like a negative x. So outside of the function is being multiplied by negative, and that's going to reflect the graph about the y-axis. So basically what's happening here is this graph is just being like flipped, right? So it's going to look something like that. Now, by reflecting it, you can see that with this bounded function, the domain and range are not changing. So my domain is still going to be from negative infinity to infinity, and the range is still going to be from -1 to +1. In the next graph here, I have the exponential function. So we talked about the exponential quite a bit in Algebra 2. And so we're just going to want to remember one key point on the exponential function is the 0.01, right? And then also that this graph has a horizontal asymptote. Okay, so that's very important because if I'm shifting this graph up or down, I want to remember that that is where the graph is going to be approaching. So I'm going to want to include that horizontal asymptote. I don't want it to make it look like this graph is going to be passing that asymptote because it's not. It's approaching it. So now let's go and take a look at our transformations. You can see here we are adding and we are multiplying. Those are different operations, right? Adding is going to be a stretch compression. Addition is going to be a shifting, right? So since we are adding, it's either going to be shift up or shift to the left. Well, since it's inside of the function, right? Outside the function would look like this. Inside the function is going to be as a power. And so therefore that's going to shift the graph 2 units to the left. And then when we're multiplying by a number that is less than 1 outside of the function, that's not going to be a stretch. That's going to be a compression. So my asymptote is remaining unchanged. Instead of the graph having this point here at 0, 1, this point now is going to be shifted 2 units to the left, and it's actually going to be at 0 or -2, 1/2, because it's actually getting compressed here. So I'm going to try to make it a little bit like compressed here as best I can. But the important thing here is, again, you kind of see where this point, what's happening to that point, but then also recognize that the domain doesn't really matter. Or it's not that the domain doesn't matter, but it becomes unchanged. It's still negative infinity to infinity. And the range is still going to be from 0 to infinity. Now, I put 0 as a parenthesis because it's at an asymptote, so therefore it's never going to be, it's not going to be defined for this function because the function is always approaching. The next graph is going to be another kind of like S-curve graph, but it's obviously the cube root graph. So again, this is, just kind of looking at your parent function, not a function we use a whole bunch, but it is something for you to kind of know what our graph is going to be looking like. So that is function. From there, we can see that our domain is all real numbers and our range is going to be all real numbers. So again, we're multiplying by negative on the outside. All right, so that is going to be a reflection about the x-axis. We are multiplying by a 1/3 inside, so that's going to be a horizontal stretch. And we're shifting the graph 1 unit up. So there's a lot going on here. So let's go ahead and reflect it, okay? And let's shift it up 1 unit. Oops, what happened to my red? I want red. Okay. And then let's stretch it. So, all right, so graph's gonna look something maybe like that, okay? Not perfect, but obviously, hopefully you can see it got reflected, it got shifted up, and I'm stretching it a little bit. But the main thing is the domain didn't change and the range didn't change because they already were all real numbers. So it doesn't matter what transformations you could apply. The next graph is the reciprocal function. And remember, the reciprocal function is going to be those, going to have 2 asymptotes. You're going to have a horizontal asymptote and a vertical asymptote. And then we just kind of have these competing, alternating parabolas against one another. So now you can see that all I'm doing is adding a 2 on the outside of the function. So therefore, I'm just going to shift the graph up 2. Now again, we can see here that my domain is restricted. So when I'm shifting, and again, this is something like kind of important to look at. I didn't really make too much like sense of the domain and range here because it was already all real numbers. So no matter what I do, it doesn't matter. But like, let's look at this real quick. If I'm looking at my domain, and I say, all right, domain is this and this. So it looks like the domain is going to be negative infinity to 0, union 0 to infinity. Okay, that's of the blue graph. Now, if I shift this graph up or down, or if I stretch it up or down, is that going to impact my domain? No, right? The only way the domain is going to be impacted is if the graph is being shifted left or right. Stretching or compressing or shifting the graph up or down is not going to impact my domain. However, the range, though, definitely is going to be impacted, right? Because you can see this graph is being shifted up 2 units. So now I have a horizontal asymptote at positive 2. So now my graph just got shifted. And so now you can see that my range is going to be from negative infinity to 2, union 2 to infinity. And that's why it's really important to redraw this asymptote so you can see how that operation, see how that shift is being applied with the asymptote. All right, our next example here is, again, we have an ln of 1 minus x. So again, we want to make sure whenever we see multiple operations inside of a function, we're going to want to write it into this format, the b times x minus c. So the first thing we're going to do here is I'm going to rearrange this. So my variable is in front of my number, and then I'm going to factor out because I want my x to have a coefficient of 1. So when I factor out the negative, I now obtain the equation ln equals negative times x minus 1. So again, this is the logarithmic function, the natural log function. And if you recall, this point has a value here at 1, 0, right? And it also has a vertical asymptote here at x equals 0. So now let's look at the transformations here. So we have a negative on the inside. That means the graph is going to be reflected about the y-axis. And then also we are subtracting a 1 inside the function. That means the graph is going to be shifted 1 unit to the right. So we can apply the reflection first and then apply the transformation. So if I reflect this graph over, the asymptote doesn't change, but now I have a new point of negative 1, 0. And then I would shift it over 1 unit to the right. So my new asymptote is now going to be at 1, 0, and I'm going to have a new x-intercept at 0, 0. Okay, so when we're looking at this, apply, and again, look at your operations. If you think about your order of operations, if this was an x, what would you do? When you plug in a number, you're going to multiply by negative first, and then you're going to add 1. And again, if you're unsure of this, plug in number 1, and what you'll get is 0. And you know that e raised to any number is never going to be 0. That's why you have that asymptote there. And you could do that for any other number if you want to verify these points. But let's just go ahead and just remember to kind of follow this order of operations, reflect before you add, and you'll be fine. Now let's go and take a look at the domain because here we had a domain of all positive numbers, but when you reflect about the y-axis, well, now that just changed to all negative numbers, and then the graph got shifted 1 unit to the right. So my domain in this case is going to be from negative infinity, and that's going to be all the way to 1. But again, at 1 is a vertical asymptote, so therefore that's going to be a parenthesis, and my range in this case is going to be negative infinity to infinity. All right, the last example here is going to be our tangent function. And again, we're going to spend a lot more time with the tangent function later on in the course. But I just wanted to kind of give you a brief little idea. And again, this graph is very, 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 very not exact because I just want to kind of make you look at the examples here. Oh, geez, I can't graph the tangent function anymore. Okay. So again, these points are not meant to be exact at all. Obviously, if I wanted you to be accurate, we would have graphing technology. But what we're going to do in this case is we need to look at, all right, what are the transformations? Now, and again, the domain here is, I'm not going to worry about the domain just because that's something we'll talk about later. So let's go and take a look at the domain. The range is going to be from negative infinity to infinity. All right. And we'll talk about the domain later. Not concerned about that at that point. But the main thing is, what about this new graph? Well, you can see this graph is being multiplied by negative on the outside. That is a reflection about the x-axis. And it's being multiplied by negative on the inside. That is a reflection about the y-axis. So basically, you're reflecting about the x and the y. And hopefully, if you remember from characteristics of functions, reflecting a function about the x and the y is basically determining if a function is odd. And if you remember, we used this example as an odd function. So guess what? This graph, if you reflect about the x or the y, is going to produce the exact same graph. Ah, very cool and interesting. Awesome. All right, guys, that is it for this video on transformations of functions. Go ahead and get some practice in the quick check quiz, and then go get started on your first quiz in this chapter, and then I'll see you guys on the next lesson. All right, cheers.